So a stationary sine wave in its fundamental mode of vibration is formed in a tube that's open at both ends. So there's the tube there, so open at both ends, and it has a length of 0.17 meters, and the speed of sound is 340 meters per second. Then you want to decide which row is correct here. We've got a number of nodes, so 1, 1, 2, 2, and the frequencies there as well. Okay, so first thing, so fundamental mode of vibration in a tube that's open at both ends. So you have to know this from memory. So we have got a tube open at both ends. It would have a node right in the middle, like this, and you would have the wave going so like that, and also like this. So the got maximums on either side, and then the node in the center there. So it has one node, so that's a fundamental. The length here, which in this case is 0.17 meters, is not the wavelength of the wave. So if you notice from, say, here, this trough to this peak here, that's half a wave. So the other half is from here to here. So the wavelength is actually twice that. So the wavelength lambda of this wave is 0.17 times 2. So that gives you 0.34 meters. So that's the wavelength. And then we're looking for the frequency. So it's, well, we know the nodes are 1, so it's either going to be 500 or 1,000. So we're going to use V equals F lambda. So the frequency is V over lambda. So that's going to be 340 over 0.34, which gives us 1,000 hertz. So the answer to that one is, so one node in the fundamental mode of vibration for tube open at both sides, and the frequency is 1,000 hertz. Just have to remember that the length of the tube in a cylinder open at both ends, it's half the wavelength. If it was closed to both ends, it would be a quarter of the wavelength, but I'll go through that in a separate video. So for open at both ends in a tube, it is half the wavelength. So the answer to that one is B.